All right. Hi. How's it going, everyone? Have you had a good first couple of days of classes? Anyone in some really cool, fun classes other than this one? Oh, come on. Seriously, you're not taking anything that's really exciting to you? Nature and society? Yeah, that sounds awesome. That definitely sounds awesome. No one else? Okay. Well, what I want to do, you get to see my cute puppy dog while we're waiting. What I want to do is first let you know there are some familiar faces in here. There's some unfamiliar faces in here. I'm Zooming every class. I'm recording every class. And what I want to do is just direct you all to, here's the Zoom link. This is on our Moodle page. Here is a link to a box folder. Every class I'm recording and any notes that we get, there were no notes from Monday, but any notes I'm also scanning and posting. So if you ever miss class, go to the box folder. That is how you can keep up with the pace of the class. On Monday, I just talked about how the classes run and kind of my overall structure of the class. So if you were not here on Monday, you missed no math whatsoever, but you did miss me talking about how I run the class. And so I urge you to go to the box folder, and when you have nothing better to do, listen to it. Okay. Essentially, my name's Lauren. Math is cool. I want you to feel comfortable in here because this is a really awesome class. College algebra is a ball, and don't be shy. Okay. We're here to learn. I love questions. I just taught my previous class and they asked me questions about every single thing I wrote down. I'm like, yes, I love that. Right, because asking questions means that you're trying to understand, and that's a beautiful thing. Okay, on this Moodle page is our course syllabus. The other thing that I want to bring your attention to is if I just need to cruise in all these to share my screen for everybody on Zoom. If you have not yet registered on this My Open Math site, that's okay, but you got to do it. Okay, this is again, as I mentioned on Monday, where each section of the text can be accessed. Once we get to online homework, this is where your online homework is going to exist, etc. Again, this is an entirely free of charge site. It works really well. As with anything that's built by humans, there's quirks and there's mistakes, what it means for us to be human. But there's a lot fewer mistakes than those websites like Pearson and My Labs and all that stuff that cost an arm and a leg and mess up all the time. So again, one of the things that I showed you, and I will take you back there, I promise, is when you get to a homework assignment. Well, I'm just going to show one more time. Like when you get to a homework assignment, you know, when we cover a particular section, I just randomly went to this one. Again, you go to it, you click right here to open up the text for that section. If you learn better, instead of reading a math book by watching short video clips, they're here. You can click on these, and then I will assign the homework when we complete a particular section. Again, I never expect you to start working on any homework before I'm done. If you want to go in and do that, I'm not going to stand in your way. However, it's really important to me to work through a lot of examples with all of us together. And for, you know, I try to pick kind of funky things that bring out different ideas and different things that can come up. So when we finish a particular assignment, you'll have a week from the day that we complete the assignment to get the homework done. Okay. You will always know when there's homework assigned, because I will literally, when, let's suppose we finish 2.2, I will literally go in and reset the due date in front of your face. Okay. So I leave nothing to the imagination. But what I want to say is, with each of these assignments, more often than not, you have little videos you can watch, which can help you. You can message me, you can message the class. Sometimes there's more than one video. So this is a really pretty cool site. And the fact that it's free is even cooler. The last thing that I want to say that I announced on Monday is that if you don't have a calculator, don't spend the money. We have calculators that you can check out of the library free of charge for the entire semester. Okay. Not at the Mansfield Library on the Mountain Campus. The calculators are here in the Missoula College Library. The one thing that I'll say is that I ordered and bought all of these calculators for everybody who signed up for a Missoula College math course. So if you're a Mountain Campus student, but you're in here, you can get one of the calculators. And I urge you to take advantage. I mean, why spend extra money if you don't have to? Okay. But I urge you to get it this week, because we started getting requests from people in the Mountain Campus math courses. And, I want to give priority to our classes, because that's what I purchased them for. However, if there's any left over, I'd rather have students use them and not have to spend money than for them to just sit here in the library gathering dust. So the priority time to get a calculator is this week. And then after this week, students who are in math classes can start checking in. Cool. So beyond tuition and fees and notebook and pens, there's no charge for this class, which is really important to me. So, I want to ask if anybody has any questions about anything else that I mentioned or perhaps didn't mention in class on Monday. None? Okay. So, well, this is kind of a bummer. Y'all on Zoom, I'm sorry that my computer's tweaking out a little bit. I'm not really sure why I can't hear you. But what I want us to do very quickly is just go around and do introductions. So what I'll ask each of you to do maybe is just type something in the chat box. And as a way to introduce yourself. Oh, cool. I don't do these introductions because I want this to feel like a high school class. I do this because, well, math is my thing. Learning names is not. And it really helps me learn your names by kind of putting things together. So we're going to start in the math, but in a moment, but I very quickly want us to do introductions. Plus, you're going to get to know each other. I mean, we're going to be hanging out and doing really cool math all semester long. So might as well know who everybody is. So what I ask you to say is your name. And if you don't want us to know anything else about you past that, I'm not here to invade privacy. But if you want to say something else about yourself, like what do you study, what your hobbies are, anything like that, please feel free to share. Yeah, is that okay? Cool. So I'll start just to break the ice. I'm Lauren, and I really love math, and one would hope, otherwise I shouldn't be here talking about it. And boy, what else will I say? I have two really cool kids. I have a 26-year-old and a 19-year-old, and I have really sweet animals and I love growing my own food, and I live in a log home about 40 miles south of town. So firewood's a very real thing, because otherwise we have no heat. And I love playing outside on my bicycle in the mountains. Yeah, I love skiing. I just love living in Montana, and I'm originally from Chicago. And those of us who are originally from Chicago certainly know very well that this is a much better place to be. Cool. May I ask you to start?
Oh, me. My name is Dylan. I'm from Texas, and I like eating food.
Cool. What do you study?
Integrated physiology and athletic training.
Awesome. Awesome. How about you?
I'm Alex, and I just moved here from Kansas City this summer.
Welcome. Welcome. You like it? I lived in Manhattan, Kansas for quite some time. Yeah. Yep. I like the Flint Hills. They're very pretty.
My name's Ross, I'm from Missoula, and I'm working on a associates of general studies.
Cool. Nice to meet you.
I'm Bailey.
Ooh, awesome.
I'm Isaiah, and I'm Spokane, Washington, and I'm going for environmental sciences in Mississippi.
I love it. I love it. Nice to meet you. I'm glad to see you here today.
I grew up in Washington, and I'm hoping to go into the.
Cool. Cool.
I'm Finn, and I'm from here, and I'm ITS major. Information technology systems, just computer stuff.
Very cool. You won't have a problem finding a job.
Yeah, that's kind of why I picked it.
Yeah, and then you can help me here too when I'm
Yeah.
struggling.
Hi, I'm Eric. I'm from Oakland, California. I'm currently I have a non-degree, and I'm not sure what to do.
May I say something? Well, yes, I will anyway. It's awesome not to know what you want to pursue, because then you're open to everything and you can take classes and find out like, oh my gosh, I never knew how cool this was. So I think it's a beautiful thing to be an undeclared major.
I'm from Chicago. I'm a psych major, and I don't know how I'm gonna do it, but yeah.
I met Kiki before the class started. That's why we have the Chicago connection.
My name's Nev. I'm from Butte, Montana, and I'm pursuing a career in dental hygiene.
Awesome.
Yes. I'm Cindy, actually from Butte. I live there and offered different places in Montana. I've lived in for 3.5 years.
Beautiful, beautiful. And now we get to read about our online friends. Thanks, everyone. Megan, very cool to meet you. And Van, same thing to you. You know, being an undeclared major just means that you're open to more things, and that's super cool. And Caden, I love the combination of physics and music performance. I think that's awesome. And I actually do some work out of University of Texas at Austin. So I spend some time down there. Well, I really appreciate everybody doing that. It's really helpful to start learning your names. Yeah. Okay. So I am going to start math. Okay. But here's the deal. I get excited because this is really cool stuff. So if you have any questions as I'm talking, there's no such thing as being polite. You just got to speak out and say, yo, Lauren, stop. Okay. For real. Do not settle for not understanding anything. I'm here to help guide you. If you need additional examples past what I do, all you have to do is ask, okay? Now, some of this stuff that we're doing at the beginning of class, I'm assuming that you've seen before, but it's really important that as we're starting out this class, that we're all together on the same page, because then we can all walk together throughout the material of the course. The way this course is structured is we do 4 chapters in this book. If you are going to be taking trigonometry after this, you're going to be using the same book, and you'll just do the latter chapters. Okay. Chapter 1 is the first chapter that we're starting with. And I know that sounds absolutely brilliant, right? We're starting with chapter 1. This chapter is like very general things and properties of functions. Functions are a huge study in mathematics. And so what we're going to be focusing on in chapter 1 are just some very big generalities and some properties of functions. Okay. When we finish chapter 1, that's when you have the opportunity to take test 1. Okay. From there, we then delve into very specific functions. So from there, in chapter 2, we're going to hone in on linear functions. And then we kind of jump out of order and we go to chapter 4, and that's when we do exponential and logarithmic functions. Once we do those 2 chapters, you'll take your second exam. And then finally, we go back to chapter 3, and we talk about polynomial functions. I like to do exponential functions right after I do linear functions, because comparing and contrasting linear growth and exponential growth, or linear decay and exponential decay, I think are very important things to bring out. Cool. So chapter 1 sometimes tends to be funky for people because it's so general. But you'll see how it progresses, and you'll have so much opportunity to do homework and ask me questions, et cetera, et cetera. Okay. Okay. So chapter 1. And again, because this class is offered blended, that's why I'm not at the board running back and forth, and I'm just sort of trying to stay as stationary as possible. All right, so we're going to start with our first section, and this is called functions and function notation. And if you're totally hip to all of this stuff and its review, what I would say to you is cool. Enjoy it while it is review, because we will soon, get a little deeper into things. Okay. So as I mentioned, functions are a huge area of study of mathematics. There are so many different sorts of functions that we can study. Again, in this class, we're doing linear, exponential, logarithmic functions, and polynomial functions. If you go on and take trig next semester, you're going to delve into trigonometric functions, and those are so cute. You'll love them, okay? But that has to wait a little bit. So what are functions? Functions essentially, in my mind, describe a relationship between 2 quantities. And I also want to mention, you can take notes or not take notes, as the case may be. I'll be posting everything that I write here to the box folder, so whatever works best for you. Now, one way we can look at functions, which is kind of, I don't know if I'd say a naive way, I kind of like the intuition, is we can think of a function as a machine and see this machine smoking because it's working really, really hard, okay? And what I'm going to do with this machine is I'm going to have inputs, and the reason why the machine is working so hard is it's going to crank out some outputs. Ooh. So, I don't know, suppose I put in my machine the number 8, And it chugs, 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 and out comes 5. And then I'm like, okay, I'm going to put in the number -11, and I'm going to see what number this machine spits out. And it's going to spit out -14. I'll put in one more number, 3, and out's going to come 0. Does anyone notice a pattern or a rule to this? What is it? You're subtracting 3. Now, if you didn't see that rule, don't worry about it. Good job, man. In other words, if I put in some general number X, the rule of this machine is subtract 3. Okay. So I used to homeschool my daughter. I homeschooled her till high school. And so we would go for hikes in the woods and we'd play what's my function. And like, she would give me a number and then I would say another number coming out and she'd have to like ask how many times until she figured out the function. Aren't you glad you weren't raised by me? Anyway, we call this side our independent side, because I just randomly and independently chose these numbers. The outputs we say are dependent, because the number that comes out certainly depends upon what number I put in. Okay. Now, we don't tend to write functions this way. It's not very eco-friendly to draw pictures of machines. And that's why we use notation. So what I'm first going to do is give you the formal definition of a function, okay? You do not have to memorize any of these definitions. I mean, number one, you get a sheet of paper with notes on your tests anyway, so memorization is already not a thing. But number two, every mathematician defines their terms because we need to be sure that we're all speaking the same language, okay? So the formal definition of a function is as follows. A function is a rule. Notice up here, the rule was, hey, subtract 3, okay? That assigns a single unique output value to each input value. A lot of words, but something that I'm going to emphasize is a single unique output value. And what I'm going to emphasize with that is as follows. Notice we usually use X values for our input and Y values for our output. I think you're all familiar with that. Is that each input or X value can go to exactly one output or Y value. If that does not happen, then you might have a rule, but it's actually a relation and not a function. Okay. Y'all with me this far? All right. Now, we have 4 different ways that we tend to write our functions. And one of the important things that we do in this class is we really try to find relationships between each of them. So different ways that we can express functions. We can have tables, we can have graphs, we can have a verbal description, or we could actually have the function notation. So what I'm going to do is just very briefly go through each of these and just give you an example because these things come up a lot. One of the things that I want to say about this college algebra course is I'm not going to ask you, for example, to factor 50 different problems. Okay, like the cookbook plug and chug sort of thing is important, but we're really going to focus on the meaning of what we're doing. Okay, because you're going to be taking these things and applying them to the real world. So, for example, and I'm assuming that you've seen these somewhat before, but I'm just making this one up. Suppose I have this table. Okay, and I'll even tell you a little bit about it. It's the number of gallons of paint needed to cover the surface of a house with a given surface area. Do you all agree that the independent variable or term is the area, and the number of gallons of paint that you need depend upon how big of an area you're going to be painting? Okay. In other words, if I'm painting 250, say, square feet, I only need 1 gallon of paint, et cetera, et cetera. Okay. Now, one of the things you need to be able to do here is take things from a table and write them as ordered pairs. So let's do that just to be sure we're all on the same page. You agree that's 0, 0. What does this one correspond to? 251 and etc. Are you all okay with that? Okay. The next way we look at these functions, or can look at these functions, are verbal descriptions. For example, the amount earned depends upon the number of hours worked, if you're paid on an hourly basis. So do you agree that the number of hours worked is your independent variable and the amount you're paid is dependent on that? Okay. Another common one is the distance traveled is a function of time. Y'all with me? Cool. All right. You're all very quiet. Anyone really thrilled so far? It's 2 o'clock in the afternoon, right? It's almost nap time. I hear it. Okay, so graphs. We love to graph functions because pictures show so much. Okay. Generally speaking, and whenever I say generally speaking, what I'm really saying is for every rule, there's an exception. Okay. But generally speaking, the independent variable is the horizontal axis. And the dependent variable is the vertical axis. The reason why I say generally speaking is some economists bebop it, but they're economists. When they do like supply and demand, they tend to bebop things. It irritates us. So, you know, I can just do like a basic linear graph. How about I just do this? And I'll even put a story to it because everybody loves a story. Suppose this is time in hours, and this is the distance traveled in miles. Notice I'm putting my units because units are certainly extremely important. Okay, so for example, starting out, I haven't gone anywhere. I'm at 0, 0. 1 hour later, I'm 60 miles from home, etc., etc. Okay, we will be doing a lot of really fun graphing. We're going to be graphing exponential functions. We're going to be graphing polynomial functions. We're going to learn some really rad techniques of doing those. We're going to graph rational functions. It's going to be a ball. So one question is, how can you determine whether a graph actually displays a function? So I'm going to draw. There's a nice little cubic function. This is called a parabola, if anybody remembers. Here's a circle. And we can have a line. I claim that a few of these are functions, but there's one that is not. Does anyone know? Good, the circle is not a function. Now you might ask me, why? Well, go back to the definition. Each input goes to exactly one output. And when you're on this circle, here's an input, but notice it has 2 outputs. Okay, so you may or may not remember this, but this is called your vertical line test. And that's how you can tell whether or not your graph is a function. So your vertical line test essentially says if all vertical lines drawn intersect the graph in at most one place, that means you have a function. Is this familiar to you so far? Okay, so for example, this polynomial is a function, right? Passes vertical line test, this passes vertical line test, etc. You all with me this far? Okay. Okay, so just to reiterate, again, you have a function if each value goes to exactly, each x value goes to exactly one y value. Okay, now there's a particular type of function. Are you okay? Okay. No, don't be sorry. I try to watch facial expressions and body language. So if anyone has a question until I get to know you, well, please just ask. You okay?
The graph in blank goes one, oh, go back. What is in blank most one place is?
This in at most
Oh,
one
at
place.
most.
Yeah, no. Thank you for asking. I have terrible handwriting. Yeah. So there's a special type of function that we're going to be talking about. And they're called one-to-one functions. Okay. We're just going to touch on them now, but they're very crucial in mathematics. So when we talk about one-to-one functions, well, in order to have a function, we know that each x value goes to exactly one y value, right? What it means for a function to be one-to-one is each y value can only be, I'll just put hit in quotes, hit by one x value. Okay, so let me draw a picture. or let me draw 3 pictures. All right. So I have these 3 pictures and I claim, I'm going to number them. This is 1, that's 2, and that's 3. I claim that one of these 3 graphs is not a function. Who is not a function? 2 is not a function. Why? Because it doesn't pass the vertical line test. Right? Notice I have this X value and it went to more than 1 Y value. If you didn't see that, don't sweat it, as long as it's clear to you now. Okay, so this is not a function. Once something's not a function, I could care less whether it's 1-to-1. We're not even paying attention to number 2 anymore. Okay, do you all agree that this first one is a function? It passes my vertical line test, as is number 3. Okay, both of these 2 are functions. So this is not a function. And sometimes I make a frowny face when it's not a function, but sometimes I make a smiley face because it means less work. So it depends on your perspective. Okay, so both of these are functions. This one hopefully looks somewhat familiar to you. This is our quote unquote basic quadratic function. This is a function, but I claim it's not 1-to-1. The reason why this friend is not 1-to-1 is, notice each X value goes to exactly 1 Y value. But if I take this Y value right here, didn't more than 1 X value bring me to it? Okay. You know, I'll write the equation of this just because I know that you're somewhat familiar with this. For example, if I plug in X equals 2, do you agree 4 comes out? But do you agree if I plug in -2 and square it, 4 also comes out? Okay, so this one is not 1-to-1. And the way you tell a 1-to-1 function is what we call the horizontal line test. This is a cute little exponential function. And I claim that this is a 1-to-1 function. It's a function because it passes my vertical line test, and it's 1-to-1 because it passes my horizontal line test. In other words, no matter what Y value I have, it's only gotten to by 1 particular X value. Now you might ask, who in the heck cares about 1-to-1 functions? This is nothing to really get into right now. We will be proceeding into it, but what I want to say about 1-to-1 functions is, as it turns out, we like to talk about inverse functions, right? Like if I'm going to take a step to my right, my inverse is take a step to the left. Okay? We like to undo things that we do. Only 1-to-1 functions have inverses. Okay. Now, of course, we can make rules to get around it. We can do things like, and I'll write the horizontal line test in a second, like Y equals X squared here. This is one of my very favorite functions to play with, right? It's so fun and whatever. But it's not 1-to-1, but we want to talk about the inverse of it. So what we end up doing is we restrict the domain to only part of our inputs, and then it's 1-to-1, and we can find the inverse function. You will be playing with inverse functions a lot in trigonometry. It turns out that that's where logs come from. Logarithmic functions are just the inverses of our exponential functions. And I'll show you how to find inverses when we get there. Okay. But what I want you to have right now is the horizontal line test. Is if any horizontal line drawn, it's the same as the vertical line test, but it's horizontal, intersects the graph in at most one place, it's 1-to-1. Are you all with me this far? I promise you, life is going to get more exciting, but we got to start somewhere. This is more definition. All right, so a couple of other things that we like to hone in on when we're talking about graphs is what's going on with our function, okay? So I'm going to draw another 4 pictures. There's one. There's 2. There's 3. And there's 4. I claim that all 4 of these pictures are functions. Okay, they all pass my vertical line test. This is clearly not 1-to-1. I mean, it fails miserably with a horizontal line test drawn through it, right? And this is not 1-to-1. Okay. So real quick, again, just to put us all on the same page, you read your graphs from left to right, the way we read the English language. Okay. It's not common in all languages. My son is studying Japanese and it is definitely not that. So things that we care about when we describe functions are where are they increasing? Where are they decreasing? And what's going on with them? When you get to the study of calculus, you're going to learn some really cool ways to tell just by the equation of a function where it's increasing and decreasing. But what would you say is happening here? As I'm moving from left to right, what's happening to my function values? They're increasing, right? Because your function values are your y values. Oh my God, but starting here, what happens to my function? It's decreasing. And then, lo and behold, what happens here? Isn't it increasing again? These are called turning points. Don't worry about the term, but they are things you're going to get to. What about this function here? What's he doing? Yeah, this one is decreasing everywhere. And I do know how to spell. How about this one here? Isn't that increasing everywhere? Looks kind of funky. We actually have a name for this function. It's our cubic function. I always nickname it the John Travolta function. I don't know if any of you have seen that terrible, awful movie, Saturday Night Fever, John Travolta. Right? Anyway, it's a very, if you haven't seen it, don't bother. And how about this one? It is constant. It's not getting larger or smaller. It's staying the same. So if you want me to write this down, I will. If you don't want me to write it down, I don't need to. But essentially, notice a function is increasing if as your x values are getting larger, so are your y values or function values. A function is decreasing if as your x values get larger, your y values or function values get smaller. And a function is constant if your function values just stay the same. Okay, y'all with me here? All right, so is that clock right? 47, I got 3 minutes. Should I use it? Okay, thanks. Okay. So I'm just gonna draw this random graph, 1, 2, 3, -1, -2, -3, and I'm gonna go woo. And then I'm gonna go down. And then starting at 2, I'm gonna go there. Okay? Would you all agree that my function's increasing here? It's decreasing here, and it's constant here. Okay, now what if I asked you, where is this function increasing or decreasing or constant? How do we identify the intervals where this is happening? When you identify the intervals where it's increasing or decreasing or constant, you use your X values. Okay, so I would say that this function is increasing. Well, notice this goes on forever from -infinity until I get to right here. What is my corresponding X value here? 0. My function is decreasing from here to here. What interval is that? Well, 0 until 2. And then it's constant from 2 forevermore. Okay, notice I'm using parentheses and not brackets because it's meaningless to say that something is increasing or decreasing at a point. Okay, so this is kind of a funky nuance for people because the way you tell whether your graph is increasing or decreasing is you look at your function value. But the way you identify the region where it's increasing or decreasing is by your X values. Tough. All right, we will play more on Friday. Was this okay so far? Okay, awesome. We're gonna play with function notation next time. I hope you all have a great day and I will see you Friday. Bye, Megan, Van, and Caden. Thank you for coming.